All right, now with the formula for the area of a sector, we can work through the example problem. You are asked to design a water sprinkler that will cover a field of 100 square yards. So it's a little bit different here. We're actually being given the area in the shape of a sector of a circle of radius 15 yards. And so here is the radius. Through what angle measure in degrees. And so the thing we're actually being asked to find is the angle in degrees. Now, we're not going to be able to find the angle in degrees initially. We're going to be able to find the angle in radians, of course, because our formula only works in radians, but we have a way of converting that later on. So we know that the area is equal to 1/2 the angle times the radius squared. And like I said, we know what the area is and we know what the radius is, so we can plug those numbers in and we get 100 is equal to 1/2 the angle times 15 squared, 225. If I multiply both sides by 2 and then divide by 225, we find out that theta is equal to 200 divided by 225 radians. Now, that simplifies down into 8/9 radians. Remember, radians is just radiuses. It's a little interesting that no pi's are involved in the angle measure in radians, but that's just a convention of the fact that we're using area and radius to solve for angle. Remember, though, we're being asked to find the angle in degrees eventually. So this is the first thing we're going to do. The second thing we're going to do is convert to degrees. And for that, we're going to use our 8/9 radians. And we're going to multiply that, putting radians in the denominator, by 180 degrees over 2 pi, over pi radians. And that is equal to 160 degrees divided by pi, which is about 51 degrees. So it's kind of weird that pi is in our degree measure and instead of our radians, but again, pi is just a number, and so it'll appear, and we could complete a sentence for this application problem and say the sprinkler should swing an arc of about 51 degrees.